In this video, we'll be talking about solving equations with fractions. So 2 main points is that when we solve complicated fractional equations, we need to find the lowest common denominator, and then we need to equate the numerators. Here's what I mean by equate the numerators. Let's say I have some fraction, let's say this is question mark, over 6 is equal to 2 over 6. Well, because the denominators we know are the same, and we know that these fractions are equal, what is the question mark? Well, the question mark has to be 2. But remember, question marks we use as x's or variables in math, so x has to be 2. So this right here is just looking at the numerator. We're just looking at the top of the fraction and setting them equal to each other. That's what equating numerators is. All right, so let's look at an example. We need to solve this equation for x. Now, the first thing we're going to do is we're going to find the lowest common denominator. If you notice that these are all fractions, this one, and this one. Now, this guy over here doesn't look like a fraction, but we know that any whole number or integer can be written as a fraction by just putting, division or a fraction bar and dividing that by 1. Now it looks like these other ones. Now, notice we have a denominator of 3, 6, and 1. We want those denominators to be the same so we can equate, like we did up here, our numerators. So in order to get the lowest common denominator, well, I can look at 3, 6, and 1. How can I get these guys to look like each other? Well, you know that if I multiply 3 and I multiply 1 by something, I think I can get to 6. So what I'm going to do is I'm going to multiply the 3 and the 1 by a multiple to get the denominator of 6. So here's what I'm thinking. What number would I multiply 3 by to get 6? Well, I multiply it by 2. But if I just multiply the top of the fraction, 2 times x, that won't give me 6. What I have to do is I have to multiply the top and the bottom of the fraction by 2. And in reality here, we're not changing the value. We're not actually multiplying some number, let's just say 3 by 2. That would change the value. What we're actually doing is we're multiplying by 1, because 2 divided by 2 is just 1. So I multiply this one over here by 2 over 2, and that will give me 2x divided by 2 times 3 is 6, minus, I'm just going to rewrite this fraction. Over here, what would I multiply 1 by to get 6? Well, that's kind of more common sense, 6. Now, if I just multiply the bottom of the fraction by 6, would that work? Well, let's check. Negative 4 over 1. And if I just multiply the bottom of the fraction by 6, that would give me negative 4 over 6. Now, is negative 4 over 6 the same as negative 4? No. So make sure that you understand, not just know, but understand why you would multiply the top and the bottom by 6. Because really here is we're just multiplying by 1. We're not changing the value. That way, negative 4 divided by 6, you can see if I divided negative 4 by 6, you get negative 4. So I have to multiply the top and the bottom by 6 because I don't want to change the value. I'm just multiplying by 1. So this is equal to negative 24 over 6. Now that we have found our lowest common denominator, now we can equate our numerators. So I'm just going to kind of drop the denominators. Now they're still there, of course, but I'm just going to only look at my numerator. So 2x minus, and remember that's a minus in front of the entire expression, 1 minus 2x, equal to, now I'm just going to drop this denominator right here, so equal to negative 24. And now I just go ahead and solve this like an equation that has one variable on one side of the equal sign, and you get 2x minus 1 plus 2x equals negative 24. We just distributed there, multiply that negative 1 outside. And again, remember guys, this sign right here I'm just using because it means therefore. I'm going to combine like terms. So 4x minus 1 equals negative 24. Therefore, I'm going to add 1 on both sides. So that means, therefore, that negative 24 plus 1 gives me negative 23. Therefore, if I divide by 4 on both sides, x is equal to negative 23 over 4. Now, this right here is a solution, is the only solution to that equation. All right. Another instance is, what if we had an unknown in the denominator? Well, we're going to do the same thing. Still find the lowest common denominator, and then equate the numerators. Your lowest common denominator here might look a little different. It's not going to be a constant or just a number, but this lowest common denominator will probably have some sort of variable in it. So let's check. First thing I'm going to do is I'm going to write this number as a fraction, negative 2 over 1. And now notice I'm going to find the lowest common denominator. So my common denominator, right now I have x minus 1 and 1. Well, I want them to be the same. So I'm going to multiply. Now if I just multiply this one over here, 1 over 1, that wouldn't change anything, right? So what would help is if I multiplied this one, x minus 1. But if I only multiply the denominator by x minus 1, that would change the value of this. We don't want to change the value. We just want to change the way the expression looks. So that means we're going to multiply by 1. This is actually just equal to 1. It's just a tricky way of writing it. Therefore, 3x plus 1 over x minus 1 is equal to negative 2 times x minus 1 over x minus 1. You can see now that our denominators are the same, so we can equate the numerators. So I'm going to distribute that negative 2 to the both terms inside. So I have 3x plus 1 equal to negative 2x plus 2. Therefore, now we solve this. We have a variable on both sides. Remember, if we have a variable on both sides, all we need to do is make sure we need to expand any brackets and collect like terms. So, okay, I'll do that. I don't have any brackets, so what I'm going to do is I'm just going to collect like terms. So I need my x's on the same side. Let's get them over to, this time I'll get them over to the left-hand side. Now you might ask, why did I get it over to the left-hand side? Because I like my variables here to be positive. So plus 2x, I'm going to add that to 3x. That'll give me 5x plus 1 equals 2. I'm trying to get this x by itself. So I'm going to get rid of the 1 from that side. So I'm going to do the inverse operation. And I get 5x equal to, not 2, 1. Inverse operation again. Divide by 5, divide by 5, because I'm only after 1x. Right now I have 5 x's. I have the value of 5 x's is 1. I want the value of 1x. The value of 1x is 1/5. Of course, we know that this is a solution to this equation. Let's check. Size. Let's check size. You can fast forward me if you want to. 3 times 1/5 plus 1 divided by 1/5 minus 1. Now, this is the left-hand side of the equation. Our right-hand side is just 2. So it's a negative 2. So in order for this to be a solution, the left-hand side has to equal the right-hand side. All right, well, let's simplify the left-hand side. That's 3 over 5 plus 1 divided by negative 4 over 5. And I'm going to simplify here. So the top here, 3 over 5 plus 1, I'm going to rewrite 1 as with a denominator of 5. So 3 over 5 plus 5 over 5, which is equal to 8 over 5. So that's over negative 4 over 5. And that just is equal to negative 4 over 5. So now I have 8 over 5 divided by negative 4 over 5. And at this point, if you're starting to get scared, I don't know how to deal with fractions and divide by fractions. Remember, your fractions divided by fractions, you leave the numerator, multiply, don't divide, multiply, and then give you the reciprocal, make the denominator reciprocal. Reciprocal just means you flip it. So negative 5 over 4. And you can see 8 times 5, negative 5 is negative 40. 5 times 4 is 20. That's equal to negative 2. Now, our right-hand side is equal to negative 2. So in fact, x equals 1/5 is a solution. That is it for the video on how to solve equations with